Okay. So, quick review where we left off. We just kind of dipped our toe into things. We specifically added some new words: elastic collisions and inelastic collisions. We said elastic collisions, that's the fancy word for bounce apart. By the way, there's also something called a perfectly elastic collision, which is a special subgroup of elastic collisions. I'm not going to talk about that, but if you're diving into internet teaching, they might mention in a perfectly elastic collision, kinetic energy is also conserved. There's something, but we're not going to look at it. And then we talked about inelastic. Inelastic are stuck together. Okay. I like example one. I like example. In fact, every question for the rest of this unit, this is what most of the written section is going to be like. It's going to be word problems, not pictures like the other day. A car traveling 44 meters per second collides head on with a car traveling 22 meters per second in the what? Everybody underline the phrase opposite direction. What does that mean? We're going to need to let one way be and one way be positive. Okay. Cody, do you want the 44 to be positive or negative? I don't care. Okay, so I'm going to put a plus sign, lazy but organized, right? I'm going to put a plus sign. Come on. Try that again. I'm going to put a plus sign. Oh, pen not working. I'm going to pause the video for a second. I'm going to put a positive right here. And then, Cody, what will I put in front of the 22? That's handy. It's starting the line. I can put a big negative so it's obvious. All right. Another trigger word is the word collision or collides. This is a collision. We're going to use conservation of momentum, the law of conservation of momentum. You can write it however you want, but I kind of like to start out by saying the sum of all the momentum that we start with is going to equal the sum of all the momentum that we finished with. Hannah, is there more than one car in this question? Lazy but organized. You know what I'm going to do above the 1.5 times 10 to the 3? I'm going to put a big capital letter A. What do you think I'm trying to hint with that? I'm going to call that one mass. Okay? Be organized, but be organized. What am I going to put above the 1.0 times 10 to the 3? Yeah. You could also put a 1 or a 2, call it mass 1, mass 2. I just don't like using numbers because I might confuse the numbers with actual numbers. All right. So, Hannah, before the collision, what's moving? Car A, car B, both, or neither? Stuck together before the collision or separate before the collision? So, you know what? I'm going to have two momentums. By the way, the plural of momentum is momenta, and I'm a nerd, a grammar nerd, so I'm going to have two momenta. I'm going to have mass, oh, change colors, Mr. Dueck. Mass of car A, velocity of car A initial, plus mass of car B, velocity of car B initial. There's the total momenta at the beginning. Yeah? Wham! They collide. After the collision, Hannah, what's moving? Car A, car B, both, or neither? I disagree. Okay. And what does it want you to find? I don't think the answer is 0. So, and by the way, that I don't think that could be the case because the only way that would work is if my initial momentum was 0. And I don't think it's going to be. So both are moving and stuck to. Okay, this is the procedure you're going to ask for a two-object collision. Before the collision, which ones are moving, stuck together or separate? After the collision, which ones are moving, stuck together or separate? How do I show stuck together? Do you remember? What did we do for masses that were stuck together? We put them inside of, yeah, it's going to be mass A plus mass B VF. Why can I do that, Hannah? If they're stuck together, they must be traveling at the same velocity. You could have them separate, by the way, but why? What are we trying to find? Which one? There's 3. Yeah, it looks like I'm going to get this by itself. Okay, let's go to our procedure. What side is it on? The right. What's going to drop down like a domino? The left side. Let's do that. M-A-V-A initial plus M-B-V-B initial. Then what? Divide by the bracket. M-A, not plus, not V, Mr. Plus MB. And Hannah, I'm going to put the VF over here. Yes? Okay, you're going to have to help me, Hannah. I've scrolled down. What are the numbers? What's M? A? Sorry. You know what? That's 1,500, which is less writing. I'm going to unscientific notation it. What was VA initial? 40, 44? Sorry, I missed that. Thank you. Plus, was mass B 1,000? What was its initial velocity? Negative. And this is, by the way, the most common mistake is missing a negative. And yeah, I'll have that as an answer to pick from if I turn this into a multiple choice question. Negative 22 all over 1,500 plus 1,000. What do you get? Oh, brackets around the top, or is there more than one? Yeah, and on around the bottom. Hannah, what'd you get? Finish it off. 25.6. Anybody else? Uh-oh, I'm seeing head shakes. Not 25.6? 17.6? 17.6? Positive or negative? Are we positive? Okay. Now, this question is kind of vague. Positive, yes. So, how about in the direction of car A? On the test, I'll include a north or a south or an east or a west so that you can clearly just write one thing. But I made this one vague on purpose. If we try and visualize this collision, Hannah, sorry for those of you at YouTube, looks like car A was the bigger, heavier car and going faster. Car B was coming in. They smashed, stuck together, and car A won the collision. Car B ended up being forced backwards. Is that all right? You can get all that information from there. Okay. Oh, is this collision elastic or inelastic? Inelastic, I'm lazy. Just do, you can write it out, but I would just circle. Example two, a really nice example of conservation momentum are curling rocks. They're great collisions. The only problem is in curling, all the masses are the same because they're identical rocks, which would actually mean the masses are going to cancel. And so what I've done is I've made up a curling question, but to make it more interesting, I'm having the rocks be different masses, which is stupid. That's not curling. But because ice is nearly frictionless, it's actually really, really good physics there. So 18 kilogram curling stone is traveling due east at 2.6 meters per second. It strikes a 12.5 kilogram curling stone is moving east at 1.2. You know what? I think what happens is one of the stones is moving slowly east and the other one rear ends it from behind because they're both east. Cody, do you see a difference in or a change in direction in this question? I see east and east. Let's let that be positive. We'll just go with it. After the collision, the first stone is moving which way? Okay, you know what? We'll let east be positive. What does it want us to find? I think Timbits. Sorry for those at YouTube. Someone's phone made a noise, and in my class, if your phone makes a noise, it was Timbits. Is there more than one mass? Let's be lazy but organized. If you don't mind, Cody, I'm going to go, how about mass A and B? Very high tech. By the way, if you want to, because I've seen some teachers or some students, they like to write out MA equals 18, MB, like the DFIC method that I did at the beginning of the year. You'll notice I'm cutting corners and letting you do things a little faster. It's really what works for you. And we're going to let East be positive. I'm just going to do that once, and that'll remind me. I don't think I'm going to get a negative answer out of this. I think what happened is the first stone slowed down. I think the second stone must have sped up because momentum has to be conserved. All right, before the collision, what's moving? Mass A, mass B, both or neither? Oh, first of all, because it's a collision, we can say the sum of all the momentum that we start with equals the sum of all the momentum that we finish with. Mr. Dueck, do I have to write that? No. If you do write that on a test and leave the rest blank, though, I will give you a 0.5. Before the collision, what's moving? Mass A, mass B, both or neither? Stuck together or separate before the collision? Yeah. So you know what we're going to have? We're going to have the momentum of mass A, so MAVA initial, and the momentum of mass B initial, MBVB initial. You know what happens next? Wham! They collide. After the collision, Cody, what's moving? Mass A, mass B, both or neither? Well, it definitely tells me the first stone is moving, and they want the final velocity of the second stone. So I think it's reasonable to say both are moving and not stuck together. Otherwise, the final velocity of the second stone would be 0.65, same as the first stone. So I'm going to have this mass A, V, A final and mass B, V, B final. All of the initial momentum has to equal all of the final momentum. What are we trying to find? Which one? There's two of them. Yep. What's going to drop down like a domino? The left side, the left side, the other right, the left side. M A V A initial plus M B V B initial. Keep going. I won't write my equals yet. I want to get the VB final by itself. I will eventually, but remember it's reverse bed mass. What else do I have to take care of on the right-hand side first? That thing. What's that thing doing? I'll minus, yeah, minus mass A, V, A final, and then divide by mass B. There you go. So we can get whatever we need to by itself. This is about as complicated as I can throw at you where there's four terms. I've scrolled down, Cody. You're going to have to read out numbers to me. So let's see. What was mass A? VA initial. Mass B? VB initial. Sorry? Thank you. Minus 18, was it 0.65? And then all divided by 12.5. If I'm visualizing this, because mass A slowed down, it lost momentum. That means mass B had to gain momentum. I should get an answer bigger than 1.2. Mass B should have sped up, I hope. So there's kind of built-in error checks, Lauren. You kind of got to think about it quite a bit, but they're there. I have no idea what the answer is here, Cody. Let me know what you got. Hopefully bigger than 1.2. 3.96, anybody else? I'm seeing heads shaking. 4.008. Okay, you're close enough. I suspect maybe a typo on one of the decimal points or something like that. So look through and find it. 4.008 meters per second. And here with no change in direction, you could call it positive or well, all the rocks just kept going. So we've done one where two objects were heading towards each other and stuck together. We've done one where objects were going in the same direction and did not stick together. What else? Oh, is this collision elastic or inelastic? They bounced apart. Pardon me? Grams, and this is a through and through. So this is a can of soda thrown due east. A bullet traveling due west strikes the can. So the soda's going this way, the bullet's going this way. The bullet continues going through. And do you see, Jada, the words east and west? We're going to have to let one way be and one way be. Okay. And yet grams. So I think the first thing I'm going to do is, nice try, Mr. Dueck. 550 grams. How many kilograms? 0.55 kilograms, and also grams. Nice try, Mr. Dueck. Not 0.12, I think 0.012, right? It's divided by 1,000. I was going to use A and B, but I think what I'm going to use actually is how about C for can and B for bullet. Don't be scared to pick letters that make it easier for you to track. You can go with A and B, they'll always work, but you know, pick letters that make it easier for you to track things. Okay, Jada, which way do you want to let be positive, east or west? So positive, positive, negative, 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 negative. Okay. I'm not sure on this one. To me, it's possible when the bullet went through the can that the can had enough momentum to keep traveling east. Sorry, east is that way for you folks. But maybe the bullet lost enough momentum that even though it went through the can reversed direction. I'm not sure. So, well, is there a collision? Then we can certainly say the sum of all the momentum we started with equals the sum of all the momentum we finished with. Jada, before the collision, what's moving? Both and very separate, yeah? So we're going to have momentum can, well, a bullet was mentioned first, wasn't it? Momentum, bullet, no, can was mentioned first, Mr. Dueck. Be consistent. Not wrong to say the bullet first, but let's do it in the same order as they wrote it. Mass, can, velocity of the can, initial. There's the initial momentum of the can, plus mass, bullet, velocity of the bullet, initial. There's the two things that were moving before the collision. After the collision, Jada, I think both moving in separate, yes? So we're going to have mass, can, velocity, can, final, and mass, can, Mr. Dueck, bullet, velocity, bullet, final. What are you trying to find? Try this one on your own. I'm going to do it up here without talking at all. I'll just leave my screen going, so if you get stuck, you can look up. Check for typos. I got a typo right there, Mr. Dueck. 0.55 times 25 plus 0.012 times negative 250 minus 0.012 times negative 55, all divided by 0.55 plus 0.12. Is it anybody else? 20.3? I'm wrong? Okay, let me double check. Might have written down the numbers wrong. I don't know why I added the 0.12 to the bottom. It was just a single mass down there. I don't know why I did that. Treating it like an Atwood machine or something. That was silly. Let's find out. 20.745 and then the 4 5s repeat? Is that? Okay. I made a mistake. 20.7. Jada, how fast was the can going initially? How fast is it going now? It didn't lose much momentum, and the reason is even though the bullet was traveling really fast, it didn't have much mass, and it went through and through. It kept some of its momentum. So momentum was conserved, but the bullet didn't transfer very much momentum to the can. Oh, direction. We do have compass directions this time. Probably should have done that for this last one because they gave me compass directions. I could have said at east for the previous one too. And you can write the word east, or if you want to abbreviate, if you're just using a single letter, we usually put an at sign because some of those letters are also symbols for other things. W is work, W is watts, W is west. It's all in context. N is newtons, N is north. Some textbooks use N for normal force. I just don't because it's too many N's. Elastic or inelastic, Jada? They certainly did not stick together. It's kind of weird to say, well, they didn't bounce apart. Well, they went through and through. It's not inelastic. What's your homework? So you can try number one. 2 is good. 3 is good. In number 2 and number 3, one of the objects is either starting out at rest or comes to a stop. I haven't done one like that, but if you're starting at rest or if you're coming to a stop, what's the momentum of the object at that point in time? I think it makes it easier. I just haven't done one like that. I like number 4. I like number 4. In fact, I liked it enough that I did 2 of them on there. That's a hint. I'll skip 6. I'll do 7. 8 is good. 9 is good. 10 is good. A little football physics. Tomorrow you're going to get, you know what? Tomorrow I think we're just pressing pause because although you'll get some time to work on it today as well. Yeah, tomorrow because I got some people away for a field trip is going to be, I think, just press pause. Okay. Let me hit stop.